So example number 2 for impulse, a car of mass 1000 kg travelling at 20 meters per second crashes into a tree and comes to a complete halt in 0.05 seconds. Calculate the force acting on the car during this time. So a force times time is, remember, is an impulse, which is the same as a change in momentum. So force multiplied by the time is the momentum afterwards minus the momentum before. So force times 0.05 equals 0 minus what? Because the momentum afterwards has come to a complete stop, right? So it's 0. So there's no momentum after the collision. And beforehand, it was 1000 times 20 because there's 1000 kilograms travelling at 20 meters per second. So this results in negative. So the force has got to be negative. It acts to stop the motion. If it's acting to speed it up, there's going to be a positive force. So minus 20,000 divided by 0.05 is the rearranged equation, and that gives our answer of minus 400,000 newtons. So the force acting on the car during this time is 400,000 newtons, and the minus sign shows that it's in the opposite direction to its original velocity. So how now can we use these ideas of impulse and change in momentum for practical purposes? So for example, reducing injury from the accidents. So for example, there was this car that's crashed into the tree, and there's a huge force that would be experienced during this crash. And how can we reduce this force? This is the idea. Ideally, if you're in a crash, you want this force to be as little as possible, and there's ways to reduce it. So if we think about what we've got, what the change in momentum depends on, it depends on the force, and it also depends on the time. So this can be rewritten, it can be rearranged. The force is the change in momentum divided by the time. So many accidents involve passengers coming to a halt very quickly. It is the force experienced by the passengers which causes injury. If the change in momentum can take place over a longer period of time, the force experienced will be smaller. For this reason, many safety devices try to reduce the impact experienced by passengers during an accident. They do this by increasing the time over which change momentum occurs. So what do you think we would have to do? Do you think that we'd have to increase the time or decrease the time to make the force less? We want the force to be less. Because this is a division here, they're inversely proportional to each other. The force and the time are inversely proportional to each other. So if we want less force, we want a greater time. We want more time. We want to slow down the impact or the effect of the impact. How can we do this? We can use a crumple zone, which extends the distance, therefore extends the time over which the collision occurs. We can use a seatbelt, which slows down the rate of movement forward. You can use a crash helmet so that the helmet itself absorbs the impact and absorbs the force. We can use an airbag so that, again, it extends the time over which the collision is occurring. So as the airbag deforms, the time is increased. And these safety features have been developed using a knowledge of Newton's laws, kinetic energy and momentum, which are the three ideas that we're bringing together in this lesson. As mentioned at the start of the lesson, where with prior knowledge of Newton's laws, kinetic energy, and we're tying up momentum today. So the crumple zone, they are found at the front of a car, because the front is usually the first thing that's going to be potentially involved in a collision, and they're designed to crush. The kinetic energy of the car is transferred to heat and sound and is used to change the shape of the metal. Instead of the car coming to a sudden stop when it hits the tree, the deceleration that the passengers experienced is reduced due to the time taken to crumple. The change in momentum happens over a longer period of time, so the force experienced by the passengers is reduced. Seatbelt. Well, all cars are required by law to have seatbelts fitted. The main purpose of a seatbelt is to prevent people going through the windscreen or into the back of the driver or the front seat passenger. When a crash takes place, the seatbelt restrains the person, but as it does, it stretches slightly. This lengthens the time over which the change of momentum takes place.